Welcome to the video for Lab Module 6, the Gram stain.
Hello. This is the video for Lab Module 6, Gram staining. As I mentioned in Module 5's video, there are several different stains that we're going to learn to do in this course. In Module 5, we learned to do a simple stain using methylene blue. In this module, Module 6, we're going to learn to do the Gram stain, arguably the most important microbiological stain being used today. It is probably done thousands of times every day in labs across the world. The Gram stain is a type of differential stain that is meant to divide bacteria into two groups based on how they stain with the Gram stain. If at the end of the staining process they have stained purple or bluish black, they are considered to be a gram-positive bacterium. If, on the other hand, at the end of the staining process, they have stained a pink or reddish color, they are considered to be a gram-negative bacterium. So a little bit of background about the Gram stain. The first version of it was developed by a fellow whose name was Hans Gram in 1884. Numerous modifications were made to his original protocol between 1884, the years 1884 and probably 1910 or 1912. I've done a little bit of investigation into this, and it seems to me by the beginning of World War I, by the way, started in August 1914, it appears that by the beginning of World War I, the Gram stain protocol had become standardized to what do we do today. What we do today, 100 years later, over 100 years later, appears to be pretty much the Gram stain protocol that people agreed on back in 1913, 1914. The Gram stain, as we do it today, uses two different staining solutions. The first staining solution used in the protocol is referred to as the primary stain. The second staining solution used later on in the protocol is referred to as the counter stain. In the Gram stain, the first staining solution, the primary stain, is actually a staining solution of crystal violet. The counter stain in the Gram staining protocol is a red staining solution called safranin. So the primary stain is crystal violet, which is purple. The counter stain is safranin, which is reddish or pink. I have them arranged in front of me from left to right. The one on the far left is crystal violet, the primary stain. The one on the far right, my far right, is the reddish staining solution called the counter stain, which is safranin. Now, it turns out there are other reagents we have to use in order to do the Gram stain. What we'll do first is we will cover the smear with crystal violet for about 60 seconds, then we'll wash that off. We'll cover the smear with Gram iodine, and then do that for 60 seconds and wash it off. Then we will use this acetone solution for the decolorizing step, and then finally, we will, of course, wash that off. And then finally, we will finish up by using the counter stain, safranin, for 60 seconds, and then washing it off and blotting the slide dry. Let me explain the purposes of the different reagents here. Of course, the crystal violet is the primary stain, so that obviously stains the bacteria all purple at the beginning of the procedure. The Gram iodine is meant to help the crystal violet stick more tightly to the bacteria. Since that's what Gram iodine does, Gram iodine is considered to be a mordant, M-O-R-D-A-N-T. The acetone is arguably the most important part of the step here because it is used for decolorization. What you want to do is you want to remove the crystal violet from all the bacteria that are not gram positive. And that's done by the decolorizing agent. And then you come back with the counterstain safranin, and all those bacteria, if there were any that were decolorized, you want to recolorize them, pink or red, using the safranin. So at the end of the procedure, if you do it correctly, the bacteria that are gram positive will keep the purple color and will look purplish or blue-black under the scope. And those bacteria that are gram negative will appear pinkish or reddish at the end of the protocol when you look at them under the scope. So let me demonstrate the procedure here. The most critical step in the procedure is the decolorizing step. These other steps are really just no-brainers because all you do is you cover the smear, you let them sit for 60 seconds, and you wash them off. But when we get to this step using the acetone for decolorizing, that's a critical step. We have to be very careful when we do it. Okay, so I made up a smear before I turned on the camera. Of course, I have disinfected my countertop. Everything's ready to go. I've got my staining dish. I have the rod across the staining dish, and I have my previously prepared smear. Now, what I did here is something your lab encourages you to do, and that is to mix together both gram-negative and gram-positive bacteria. And that's what I did here. This is a smear to which I added two different kinds of bacteria. The one bacterium is E. coli, which is a gram-negative bacterium. It should be pink at the end of this procedure. And the other bacterium I mixed in with the smear was, or is, Staphylococcus aureus. Staphylococcus aureus is a gram-positive bacterium, and so it should be purple at the end of the protocol. So if I do the protocol correctly, when I examine this stained smear under the microscope, I should see mixed together purple bacteria and pink bacteria. Now, as you already know by this point of the course, bacteria can have different shapes. Staphylococcus is a coccus. It has a spherical shape. And E. coli is a rod and has a rod-like shape. So at the conclusion of the gram stain, I should not only be able to see that the Staphylococcus is purple and the E. coli is pink, but I should see that the purple bacteria, the staph, are spherical, and the E. coli, which will be gram-negative, should be rods. So I'll be able to see a couple different things at the end of the gram stain. I'll be able to see that one bacterium is gram-positive and the other bacterium is gram-negative, and I should also be able to tell the difference in shape. Spherical in the case of Staph aureus, rod shape in the case of E. coli. Well, without further ado, let's just go into the protocol. So I have my previously prepared smear on this slide. I put the slide on the rack, smear side up. I take the crystal violet and I cover the smear with crystal violet. I want the smear to remain covered for at least 60 seconds. You'll notice this time I have gloves on. I didn't forget. Crystal violet stains the skin pretty significantly, so I don't want to take any chances that I'm going to be walking around with purple fingers for a couple of days. So I'm wearing my gloves. Okay, it's been 60 seconds. What I need to do is take my water bottle and I need to wash off all of the crystal violet on the upper surface and the lower surface of the slide. And I think you'll be able to see this when I hold this up for you. You can see that the smear has picked up the purple stain. Look at that. When I started, it was very hard to see the smear on the video camera, but now you can see it. So that's the first step. Stain with crystal violet for 60 seconds. Second step, cover the smear with gram iodine, which is functioning as a mordant, and leave the iodine on the smear for at least 60 seconds. Again, we're going to cut away so you're not seeing here. We're just watching the iodine do what it does. Okay, we're back. It's been about 60 seconds. I'm now going to take the slide. I'm going to wash off the gram iodine, top of the slide, lower surface of the slide, shake off the excess water. And now we come to the critical step. And I'm going to turn this staining rack around so it's a little easier for me to handle the slide. So here's the slide. You'll notice the smear still has a purplish color to it. The reason you can see this so clearly is that I used agar cultures of the E. coli and the Staph aureus when I made this smear. And whenever you work with agar cultures, you tend to get a smear that is somewhat thicker and a little easier to see. And so the color of the smear is much more obvious. Okay, now I'm ready for the decolorizing step. And I'm going to follow the instructions in your lab manual, which means I'm going to take the acetone in this bottle and I'm going to cover the entire upper surface of the slide where the smear is with the acetone. And as soon as I start putting the acetone on the slide, I'm going to start the timer and I'm going to leave the acetone on there without disturbing the slide for 20 seconds. At the end of 20 seconds, I then will grab the slide, tilt it, and begin washing the slide with more acetone so that the acetone is dripping off the end of the slide into the staining dish. And I'll do that for about 10 or 12 seconds. And then I will immediately wash the slide with distilled water and go on to the next step, which is addition of the counter stain called safranin. Okay, so here we go. So the clock is ticking. And I am going to leave that acetone on there for 20 seconds. And the timing is really, really important. So I'm just going to leave the video on the whole time this is going. And when I get to exactly 20 seconds, I'm going to grab the slide, hold it at an angle, and then continue washing it off with acetone. So here we go. I grab it. And now I squirt fresh acetone above the smear and allow the acetone to run across the smear, dripping into the dish. Once there's no more purple coming off, and there isn't, I stop that. I also wash the back. And then after I shake off that acetone, I come back with water immediately and I wash the acetone off. You've got to get that acetone off there with the water because otherwise it'll continue to decolorize and you'll get erroneous readings, erroneous results. Shake the water off. And now we don't have to rush at this point. We can just grab the counter stain, which is safranin for the stain, and we will cover the smear with the red counter stain, the safranin. We will leave that safranin on for at least 60 seconds. Again, I'm going to cut away and come back. So I'll see you in a second. Okay, it's been 60 seconds. I'm going to take the slide, tilt it, and rinse off using water the safranin. Both sides, top of the slide, top surface where the smear is, and underneath the bottom surface. You don't want to have crystal violet or safranin stuck to the lower surface of the slide because it'll make it hard to focus under the microscope. Okay, now I'm done with the staining dish. I'm going to grab paper towel and blot. And I'm done. All that remains is for me to put this under a microscope, focus under oil immersion, and see if in fact the Staph aureus is still purple and the E. coli are pink or red. course, I'll know I'm looking at Staph aureus because Staph aureus will appear as very tiny spheres, and I'll know which ones are E. coli because E. coli will appear as tiny rods. So hopefully the spheres will be purple, blue, black, and the rods, which are E. coli, will be pink or red. That's it. I'm not going to show you the focusing of the scope. I showed you that in the Module 5, part 2 of the Module 5 video, and that's all I'm going to do. Again, I'm going to dispose properly of this solution. I'm going to put it in the waste bucket. I'll get everything off the island, and then I will disinfect the island, and we'll finish up and leave the lab. Just one note, in Module 5, I kept referring to Module 7 as the acid-fast stain. Actually, the acid-fast stain is exercise, or Module 8. Module 7 is actually the spore stain. So if I confused you on the previous video, I apologize. So Module 7 is the endospore stain. Module 8 is actually the acid-fast stain. Thanks.